Okay, Assalamualaikum. Okay, welcome back to the third video. So now we will look through what is limit at infinity. Okay, so here are a few examples. We would like to find the limit of the following at infinity. If you look at here, we consider when x is approaching positive infinity or negative infinity, or x approaching infinity is just the same. It's just that it's from different direction. Okay, so what happened is when you apply substitution, limit x approaching positive infinity is a very big positive number, 2x squared plus 4. So when you do substitution, 2 over this is just a random concept, um, to make you more understand, by imagination. If you look at the question, 2 over positive infinity and then you square plus 4. So positive infinity is already a big number. When you put a square, it will become a big number. Plus 4, it is still a big number. So basically 2 is dividing by a very big number. 2 divide a very big number is equals to 0, right? So in the limit process to solve, you have to divide, you have to look at the x, the highest power of x, in this case is power 2, so you will divide by each term in your fraction. 2 over x squared over x squared, 4 over x squared. Okay, we will divide it, and what you get is 2 over x squared over x squared over x squared. This one will become 1, 4 over x squared. So in this case, how they get 0 here? 2 over infinity square value. 2 divided by a very big number is 0 over 1 plus 0. Okay, 0 because 4 divided by a very big number is 0. So you will get 0 over 1. So it is actually equals to 0. Okay, same thing with this, can? But don't answer like this in exam. This is just a concept to make you more understand. What you have to do is this solution in your exam. You have to show that you divide by the highest coefficient power of x. Okay. Next is infinity over infinity. How they get infinity over infinity? Using the same concept here, when you substitute a big number, you multiply by 4, you still have a big number. You plus by 4, you have infinity value. Same thing for the denominator. Okay, so you have infinity over infinity. So this is we call as indeterminate form as well. Previously is 0 over 0. So what we do is we divide by the highest power of x. In this case, x lah, x power 1. So 4x over x plus 1 over x over 2x over x plus 3 over x. So you will get 4 plus 1 over x divided by 2 plus 3 over x. Okay, next is how you get 0. We get 0 because 1 divided by infinity. 1 divided by a very big number is 0, can? So final answer is equals to 2, right? Very easy, can? How about this one? This is not a fraction, but we will apply that conjugate method because this is infinity minus infinity. Okay? Infinity square is very big number, minus 2 is still a big number. You square root, you still get a big number. And then a big number minus a big number, maybe that x is greater than this one, you still get a big number. But we call this as indeterminate form as well. Okay, so what we do is we apply that conjugate method. We multiply with its conjugate. This is, we make it a fraction divided by 1, and then this is the operation again. So we apply with the conjugate plus. So what you get is this, and 2 over x plus set of x squared divided by 2, and then we divide by x. Okay, not x squared. Inside here you divide by x squared because x squared, this is inside the set. Okay, the outer one you divide with the x. This one divided by x, divided by x. Okay, so we'll get 0 over 1 plus set of 1 minus 0. So you get 0 over 2 equals to 0. So 0 over 2 equals to 0. So you will get 0. Alright. So settle for limit at infinity when limit is approaching a constant value that you get infinity. Okay, now we will look through what is vertical asymptote and horizontal asymptote, how we define that asymptote, and we shall discuss the shape of the graph of a vertical and horizontal asymptote. Okay, sketching the graph. Okay, a line x equals to a is a vertical asymptote of the graph of a function y equals to fx if either limit x approaching a plus is going to plus minus infinity, or x is approaching a negative and then the limit is approaching plus minus infinity. Okay, tengok sini ya, you look at here. Okay, your fx is approaching positive and negative infinity. We call it as vertical asymptote. For example, in this case, x squared over x plus 1, x minus 1. So basically we know x cannot be 1 and x cannot be negative 1. This is easy lah. Okay, so we draw that vertical asymptote. Okay, now we will check what happened to the limit lah when x is approaching negative 1 from the left and right side, and for the x equals to 1 as well. Okay, we will check the limit here. Limit x approaching negative 1 negative from the negative side. Here is your negative 1 from the negative side, from left hand side. X squared over x squared minus 1 equals to positive infinity. How they get positive infinity? Okay, how we get this positive infinity? So if you look at here, negative infinity, negative value kan? Negative value. So if you want to make it easy, you imagine with you put a value here, like for example negative 1.1. okay, and then you substitute here negative 1.1 square over negative 1.1 square minus 1 kan? So you will get a value here. This value will be approaching 0. Okay, so a big number divided by 0 is approaching infinity. Okay, is approaching infinity. But that infinity, is it positive or negative? Okay, we will look at here. Negative 1.1 square is positive. Okay, negative, this one is positive and it is bigger than 1. So a positive number bigger than 1 minus 1, you will get positive value here. Okay, so it will be approaching positive infinity lah. Alright, so positive infinity maksudnya meaning that your graph will be going up. Positive infinity kan, going up. Alright, so now we will look if it is approaching a negative 1 from the right hand side. Okay, how they get negative infinity? Same thing, negative infinity. So here negative 1 positive. So let's say we choose a very small number near to negative 1. Let's say negative 0.9. So negative 0.9 square over negative 0.9 square minus 1. Okay, this value is a positive value. Divide by, okay, this value negative 0.9 square minus 1. What you get? It should be a negative value. Okay, negative value that approaching to 0. So positive number divided by negative value approaching to 0. It is approaching negative infinity. Okay, because it's divided by 0 kan? Any number divided by 0, you will get infinity. Okay, same thing when it is approaching positive 1 from right hand side and left hand side. Okay, so you will get positive infinity for right hand side, so it's going up, and then negative infinity when it is approaching from the left hand side of 1. Okay, now you have this sketching. Okay, sketching for vertical asymptote. What happened to your graph when they are up near to your vertical asymptote? Okay, now we will look at the definition of the horizontal asymptote. Okay, horizontal asymptote is when your x is approaching positive infinity or negative infinity and it is approaching a constant. Okay. Okay, and this one, when we apply with this graph, okay, what happened when this x is approaching positive infinity? You have to find this limit x approaching positive infinity, fx. What is the value? Okay, we have to apply the method from the finding limits at infinity. So when we substitute inside here, limit x approaching positive infinity x squared over x squared minus 1. So in this case, we have to divide by x squared over x squared over x squared minus 1 over x squared, kan? So you will get 1 over 1 minus 0, kan? So you will get 1. So it is actually having horizontal, it is approaching 1. It is approaching 1. Okay, it is approaching 1 here. There is example, the continuation of that. Where is it? Just now. This one. This is the example. Okay, limit positive infinity is approaching 1. So you have that horizontal asymptote at y equals to 1, where your graph just now you have vertical asymptote here again, and then here, and then when x is approaching positive 1, so you will have, we just let them meet each other, the line, kan? We just continue the line and going like that. Okay, so the graph for the first part is here, and then just now you have a vertical asymptote at x equals to -1, and here is the when x is approaching from negative and right side of -1 and 1. Okay, what happened when x is approaching negative infinity? Same thing, you have to divide with x squared over x squared, so you will get 1 as well. Okay, so you have this line, so we just continue this. Okay, now you already sketched this part and this part. Now you have to find the middle one. Okay, so how will your graph look like? You can find randomly one point of intersection here. For example, when x equals to 0, your y will be 0 square over 0 square minus 1 will be 0. So you have one point of intersection at the origin. So you just continue the line. So this is the graph. This is the graph. Yeah. Okay, so I already covered how we strategy for graphing rational function. Okay, step 1, you have to find intercept. When x equals to 0, what happened to your y, and y equals to 0, what happened to your x? Either one lah. And then find the dominant terms, find the asymptote. Asymptote is, look at the denominator. In this case, x not equals to -2. So you already have the vertical asymptote. X cannot be -2. Okay, and then horizontal asymptote when x is approaching positive infinity and x approaching negative infinity, and then choose x values between and beyond vertical asymptote and the x-intercept and construct a table for values, and then draw the smooth curve. Okay, for example, like this, step 1, when x equals to 0, you get this. So you have one point of intersection at 0, -3/2, and then another one here, okay, dekat paksi x and paksi y. So here is your x, here is your y, 0, 3/2, somewhere here, -3 and 0. So you have 2 point of intersection there, okay, and then find the dominant term. So 1 plus 1 over x plus 2, because your graph having the same power of highest power of x, 1 and 1, so we can divide it. So we get this 1 plus 1 over x plus 2. Okay, find the asymptote. So x -2 is the vertical asymptote. So once you get that vertical asymptote, you have to look through what happened to your graph when x is approaching your vertical asymptote from positive side and from negative side. Okay, so you need to see what happened to them. Is it approaching positive infinity or negative infinity? You have to check. Okay, and then applying the horizontal asymptote, this is excuse me, limit x approaching positive infinity or limit x approaching negative infinity for that horizontal. Okay, for that horizontal, you have to find the limit approaching infinity. For vertical, you have to find the limit on that vertical. Okay, and then choose x values beyond, between and beyond the vertical asymptote and x-intercept. This one you can do, you didn't do also can. Okay, this is the example. Okay, draw the smooth curve through the intercept and the points from the table so that the portion of each curve approach an asymptote, so that the portion of the curve moves away from the origin. Okay, this is the y-x-intercept and y-intercept. So this is just now is x equals to -2, the vertical asymptote. So once you get your vertical asymptote, you have to check x approaching -2 positive and limit x approaching -2 negative. So just now our fx is equals to 1 plus 1 over x plus 2 kan? Okay, so here is 1 plus 1 over x plus 2. Alright. So in this case, -2 positive, -2 positive from this side lah. Okay, -2 positive, if you substitute some value from the right hand side of -2, let's say is negative 1.9. Okay, so it is actually you substituting -2. Okay, -2, it is not -2, you are substituting a value approaching -2. Okay, approaching -2 from right hand side. Okay, meaning that -2 plus 2, it is actually approaching 0, but that approaching 0, is it positive or negative value? Okay, so usually I will substitute any value that near to -2 from right hand side. For example, -1.9. So 2 minus 1.9 is a positive value. So it happen is 1 plus 1 over 0, because it is approaching 0. Positive 0, approaching positive 0. So 1 over positive 0 is a positive infinity. So positive infinity plus 1 is a positive infinity. So that's why the graph is going up like this. Okay, so next is 1 plus 1 over x plus 2 from the negative side. Here, negative side. So if negative side, meaning that is negative, I substitute -2.1. Okay, the value will be approaching 0, negative 0. We cannot say negative 0 because 0 can't be negative, can? Negative 2.1 plus 2, okay, you will get a negative value. So 1 over negative value is a negative infinity, because 1 over value that approaching 0, so it's a negative infinity. So 1 plus negative infinity, you will get negative infinity. So that's why this is going down. Okay, and then this is for horizontal. For vertical. For horizontal, you have to find limit x approaching positive infinity from this side. Okay, 1 plus 1 over x plus 2 equals 2. All right, so in this case, x over x, 2 over x, 1 over x. So 0 over infinity plus 0 is 0. So 0 over infinity is 0. So 0 plus 1 is 1. So limit x approaching negative infinity also the same. It is equals to 1. So you get this horizontal line. Okay. Can understand, kan? So this side and this side. So now we just sambungkan that point of intersection and the one that you find from the limit of horizontal and vertical asymptote. Okay, this one is I already explained. Okay. Okay, this is the exercise. You can try by yourself. Exercise, compulsory. You have to submit it to me. Okay. I already have the answer. You just try. You have to try, yeah. So you don't have to submit to me because it's already here. Okay, this is another example. Find the vertical asymptote of fx equals to 1 over x squared. So in this case, x cannot be 0. So the vertical asymptote will be the y-axis. Okay, so they find limit x approaching negative, they get positive infinity. 0 positive, they get positive infinity. Thus the line x equals to 0 is a vertical asymptote lah. Okay, memang ngam lah. Okay, and then this is another example. Examine the function sketched in this figure as x approaching negative infinity fx approach but never quite reach a value of 4. Okay, as x approaching negative infinity going down like this. Okay, it is actually not equals to 4, it is approaching 4, but we put it as 4. But it will not cross at this line y equals to 4. Okay, this is also the same. Similarly, in this graph, in this figure, g approaches but never could reach the x-axis as x approaching infinity. So we can state this behavior by notation limit x approaching infinity, gx equals to 0. Just now, the limit notation we state as this. X approaching negative infinity equals to 4. And this one, the notation is limit x approaching infinity equals to 0. Right? This is the solution just now lah. You can look through. Another exercise you can do by yourself. Okay, the last one will continuity. I will discuss in the next video. Okay, the last video, right? Thank you. See you.